Hi everybody, welcome to Lecture 2, Chemistry in the Body. We're going to do part 1 out of 5 parts, and in part 1 we're doing basic chemistry, elements, atoms, and subatomic particles. The column on the right of the slide represents the hierarchy of life where biological structures are organized from simplest to most complex. We're going to start off today at subatomic particles, and throughout the semester we're going to start climbing up the hierarchy till we reach ultimately up to the organism. I want to start off this lecture by saying we are all made out of stars. There are many native tribes around the world that trace their ancestry to stars, and they refer themselves as star people or star nations because they believe they are descendants of stars. I think this is so fascinating because these native people knew they were made out of stars prior to Western technology. Western technology was not able to determine the composition of stars until the 19th century, which then now confirms that we do literally are made up of the exact same elements as stars. Each color in this human outline represents the percent makeup of an element or elements that are found in our body. Majority of our body is made out of oxygen, carbon, hydrogen, and nitrogen. In smaller concentrations, which is represented by the yellow area of the foot, are elements that are necessary for life. You know from anatomy that calcium makes up bone. However, in physiology, you will learn that calcium is important because we need it for muscle contraction. For example, skeletal muscle contraction allows us to be mobile. Contraction of the heart is necessary for pumping blood throughout the body. And then also, when we contract smooth muscle around tubes like the GI tract, it allows us to digest and move our food. Sodium is another important element that is necessary for life, and without it, we would die. If you remember this slide from last lecture, we observed that cells actively pump sodium outside of its membrane. This causes the cell to have a charge, where the outside of the cell is positively charged and the inside of the cell is more negatively charged, exactly like the batteries we use in our electronic devices. With a disequilibrium of charges, our cells can do work, which we'll get at after midterm 1. Lastly, our body is made out of trace elements, and they are called trace elements because they are present in very small amounts, and that is represented by the purple toes. One of these trace elements is iron, which is found in hemoglobin in our red blood cells. Iron pinches or captures oxygen, and without it, we wouldn't have the oxygen we needed to sustain life. Now, I do not want you folks to memorize all the elements and all the percents that they make up. However, in your homework, there is a question that asks you to match some of the elements with why they're important in the body. The elements on the homework are the ones that are important for this class. Before we get into the anatomy of an atom, I wanted to briefly review the periodic table, which shows us all the atoms known to man. Their order is from atomic numbers 1 through 118, is based on how many protons they have in their nucleus. So if you're hydrogen, your atomic number is 1, and you'll have 1 proton in your nucleus. Now, do not memorize the periodic table. I think you had to do some of that or all of that in chemistry. This is just a quick chemistry review to make sure that we're all on the same page. Throughout the semester, I'll reference pop culture, social media, and some of the things that are going on in the news while I'm teaching a topic because I feel that it's relevant. If at any time you don't know what I'm talking about, please ask me so I can fill you in so that you're on the same page as me. Now, today I'm going to reference a TV show called The Big Bang Theory. Now, I love this show, especially Sheldon. He is my favorite. He makes me laugh so much. Whenever I'm grading and I want to stay happy, I'll pop one of these in the background so I can giggle and I'm nicer on the grades. Now, majority of the characters on this show are physicists, and if you watch this show, you will notice that they're always using the word subatomic particles. They say it a lot. Now, we have to ask ourselves then, what are subatomic particles? So protons are positively charged particles within the nucleus of an atom. And the neutrons are also found in the nucleus of the atom, but they are neutral. No charge. And then lastly, electrons are negatively charged particles that surround the nucleus and they're constantly moving. And because they're constantly moving, they're creating something called a negatively charged cloud. This is a helium atom. It is the second element in the periodic table and its atomic number is 2. So the atomic number then is going to dictate how many protons, how many neutrons, and how many electrons an atom has. So helium, because its atomic number is 2, will have 2 protons, 2 neutrons, and 2 electrons that orbit around the nucleus. Electron vacancies will determine how atoms come together to form molecules. Now, electrons travel in regions called shells, which is the orbit electrons travel around the nucleus. So if here, I'm going to draw a nucleus, I'm going to label it N, and then I'm going to draw the first shell, and this is this first orbit that's directly near the nucleus, and this is going to be the first shell, and the maximum amount of electrons that can be carried in the first shell is 2. Now, the second shell is outside of the first shell, and this can carry 8. And so I'm going to label it 1, 2, 3, 4, 5, 6, 7, and 8. And then you can see by the way that I'm drawing the electrons is that electrons like to travel in pairs, and so that's why I'm drawing those 2 little circles together. Now the third shell is larger and it can carry a max amount of 18 electrons. However, in order to be stable, it just needs 8. So if I go ahead and draw 1, 2, 3, 4, 5, 6, 7, and 8. So to review, because this is important for the next part 2 of this lecture, in order to be stable, the atom in its first shell must have 2 electrons, and in its subsequent outer shells, it must have 8 electrons. Now let's look at the vacancies for hydrogen, carbon, nitrogen, and oxygen. So here you can see hydrogen has only 1 electron, so it is going to need to acquire another electron to be stable so that its first shell has 2 electrons. Now carbon has 6 electrons. 2 are going to fill the first shell, which is now stable, and then the remaining 4 electrons are going to fill the second shell. So carbon needs an additional 4 electrons in order to be a stable atom. Nitrogen, you can see, has 3 unpaired electrons, so of course it's going to need 3 electrons for stability. And lastly, oxygen needs 2 more electrons to fill its outer shell. Now we're done with part 1 of this lecture. In the next video, we're going to go into part 2 of this lecture where we're going to further discuss how electron vacancies or valencies determine the chemical bonds.